Hi, my name is Bill Laboon, and welcome back to Blockchain Fundamentals. In today's lecture, we're going to discuss using a simple blockchain as a platform. And when I say a simple blockchain, I mean based on the same basic concepts that we learned with the basic Bitcoin blockchain. So obviously, there are a lot of other blockchains out there that have additional features and things that are built in. But I want to talk about using, from a very, very simple perspective, what all can we do with a blockchain besides just use it to store currency. So again, so looking at Bitcoin, we can think of the Bitcoin network itself, the Bitcoin blockchain, as an append-only log, which is permanently storing data. Now, obviously, permanent means can mean something different, right? Depending on what your definition of permanent is. But generally, when we're looking at a blockchain, we consider that this data won't go away. We are only going to append to it. We're going to add to the end, but we are never going to go and delete things earlier. We know that it's a time stamping service, since every block not only has a timestamp on it, but also we can use it to prove that one block occurred after another. So we can always look to see what order things came in. It's a means for value transfer. So generally this trusted value transfer was in the form of Bitcoin, but we can think of this in more abstract ways, as we'll see in this lecture. It's a way to commit information cryptographically. That is, you can prove that you actually said something and you committed it by committing it to the blockchain and signing it. And if it comes from your account, then you can say that you have actually said it in the past. And we talked earlier about cryptographic commit schemes. And finally, it's a way to prove identity. So there is, if you have the private key to an account, then if you sign something with that private key, you can also prove that you own that account. According to Bitcoin's definition of ownership, which is knowing the private key. Of course, if you do this in multiple places, then you can prove that it's the same person or same entity, or again, the same someone else who knows that same private key. And you use that as a way of proving the same person is sending a message or transmitting something from various disconnected messages. So we know that with Bitcoin, we can provide very secure timestamping, since producing a block is very difficult. And remember, we discussed in a previous lecture how making block production somehow difficult is one of the key ways we can provide security to a network. And so by doing this, we can by having this, it's very difficult to add blocks to the network. We can show that if you know a block hash ahead of time, then whatever event occurred at that point, if you know the block hash, then you can prove that it happened after that event. So there was actually a very famous incident of this, where there was a rumor that Vitalik Buterin had died, and he posted a picture of himself. I have the link to the Twitter tweet where he tweeted this out, that proved that he was still alive because he is showing the block hash of a particular block. And this is on the Ethereum blockchain. So he joked this is proof of life, proving that he is still around. it's the same idea if you've ever seen an old movie where the kidnappers have the hostage hold up today's newspaper to prove that the person was still alive and able to hold up a newspaper. Since it would be very difficult, at least at the time, many of these old movies were made, to generate an entire fake newspaper. So similarly, it would be very difficult for Vitalik or whoever was faking this to know that block 3,930,000 would have that particular hash. Okay, so another thing you can do is commit to specific information. So remember that the SHA-256 hash function, or really any good cryptographic hash function, should be collision resistant and hiding. So what this means in layman's terms is that if I say something and post the hash, it should be very difficult for anyone else, computationally infeasible, to find some other message that could hash to that value. And also it's hiding. So it's going to be very difficult for someone to know what that message was ahead of time. But if someone says what the message is, it should be trivial to verify that it was the correct message. Since you remember, hash functions are essentially one way. So again, not proven to be one way, but for all practical purposes, one way. That we going in one direction, giving the message, determining the hash is very simple, but from the hash, determining what the message was, very difficult. So between this and being able to prove with our identity that we were the particular person who posted something, we can use our commitment scheme to commit to a message to prove that we made a specific message at a specific point in the blockchain. Now, with Bitcoin, obviously the time is going to be a little variable, since block production time is variable, since there's some flexibility in the timestamp itself, but it allows us to commit to particular messages in the blockchain. So there are some problems with this, though. It's something you could use it to do is to prove that you are, in fact, clairvoyant. So let's say on Friday, the Steelers football team are playing on Sunday, and on Friday, I post 3 messages to the blockchain. And one says they'll lose, one says they'll win, one says they'll tie. So we have eliminated, we've covered all of the options. It is a totally covered function here. And then on Monday, I claim to everyone else, hey, I saw the future, by only revealing whichever commit message actually said what happened. So there are a few actual instances of this. A famous one, somebody actually had a whole list of tweets that said exactly what would happen in a football game and exposed this after the game. But the tweets were time-stamped from several days before. And how this occurred was the person had put thousands and thousands of possible messages that this person scored a goal, this person got injured, the game ends with this particular score, etc. And then just went back and deleted the ones that didn't match up with what actually happened. So there are a few ways that we can work around this. If we have an identity, we can see what all was published under that identity, and that identity would have to be published ahead of time, right? And the message revealed, right? So we say what the hash is and ensure that it is linked to our identity ahead of time so that others can actually determine that there were this and only this message was sent, and not a whole bunch of messages, and then after the fact determining which ones we want to reveal. But it is an interesting way of, for instance, proving a bet. So if you let's say you think that you know that something is going to happen, but you don't want to tell people because you think it might influence them. You might say, hey, I know what's going to happen with this. Like, I know who's going to win the presidential election or something like that. And let everyone know, post a message under, with, and say this is a hash of that message, of the prediction. And then you can reveal what the value was, and it'll be trivial for anyone to verify that that was in fact what you said earlier. So this can be useful. I've actually seen it in a few Facebook posts where people were arguing about the results of a particular political situation, but didn't want to claim anything until after it occurred. So it is a nice way of revealing information later while committing to it earlier. So another thing we can think of that a blockchain does is permanently storing data. Now, when we say permanently, we can very easily get into the realm of, well, heat death of the universe, what happens if the Earth falls into a black hole and information is destroyed, etc. But for our purposes, we can generally consider permanently, in the span of lifetimes, that data, once added to the blockchain, is stored. And this data is stored on numerous locations. So in Bitcoin, for instance, every full node is going to have, perhaps tens of thousands of computers are going to have a copy of the entire blockchain. And these locations have a lot of reason to maintain that copy, right? Because they will, by having that data, that enables them to run a full node and either mine or verify transactions. So by using OpReturn, we can store up to 80 bytes of arbitrary data in a transaction. So this is enough for a short message, for a link to something, for a hash value, like a message digest of resulting from a hash, whatever. And this is kind of cool, right? So for the price of a Bitcoin transaction, we can store this 80 bytes permanently. So I have actually used this to write a Valentine's Day message to my wife because I'm a romantic like that. But it is rather controversial. So some argue that Bitcoin is meant as a place to transfer value. It is not meant as storing other kinds of data. However, there is also others who argue that if people are willing to pay for this space on this blockchain, then they should be able to do it. So it is quite controversial. There are actually, Ethereum and other blockchains really try to discourage doing things like this because it leads to state bloat, things that aren't specifically good at storing on the blockchain. But for all of these, for any system that I'm aware of, there's probably some way to store data. You can even use, for instance, an address. Right? If you generate an address based on a specific seed or as a hash of something, and if you don't care about actually using that address, you can just send to an address that says something, and that address will now exist on the chain. People will be able to query it, and you could store like the ASCII the ASCII equivalent bytes or something like that, so there can be actual messages on the blockchain embedded in addresses. So it's very hard to avoid people storing data on the blockchain, but just be aware it is definitely there is definitely some controversy over whether it's something that should be allowed. And depending on the blockchain, there are going to also be different schools of thought. So obviously, Bitcoin as the largest and oldest blockchain, there's a very broad spectrum of ideas. But other blockchains like Bitcoin SV they really relish and revel, I guess would be a better word, in the fact that you can store a lot of data in their blockchain, and they do not discourage it at all. So if anyone can push this arbitrary data onto the blockchain, right? Well, I guess I've got a typo there, arbitrary, but no. So if anyone can do this, and remember, we just said it's very difficult to stop someone from doing it because you could even put it into an address or something. So what's to stop them from sending illegal data? And of course, by whose jurisdiction do we mean illegal data? Well, it turns out there is nothing stopping you from doing it. There is no CEO of Bitcoin or really any decentralized ledger. That's part of the point of being decentralized, and it's immutable. Once that data is up there, then it's essentially impossible to get rid of. And if you search the blockchain, you'll actually find a lot of illicit data on there. So I've linked to it, some of it illicit, some of it just interesting. So I've linked a paper, quantitative analysis of the impact of arbitrary blockchain content on Bitcoin. And they did a search through the blockchain at that time. I think this was from 2014. And looked for interesting things that were data that was not part of transactions. And they found all sorts of stuff: wedding images, chat logs, backups of WikiLeaks dumps, news articles, links to various things on the dark web. All sorts of stuff was found on the blockchain. But remember that if you are running a Bitcoin node, you are also storing all of that data. So this can be considered an attack against Bitcoin, putting arbitrary data, especially illicit data that nation-state actors may be wary of. And anyone running Bitcoin now has this illegal data on their computer. So this is certainly an attack, right? That is possible. Somebody theoretically, could say that you're storing data that goes against, the laws of the country that you're in. If you're running Bitcoin, you need to have the blockchain in order to run a Bitcoin full node. So illicit content attacks, something to be aware of, and as I said, that's a really interesting paper. I recommend you go through it. So other things that you can do, one is smart property. So remember, Bitcoin by themselves, and really any token, doesn't really represent anything. So a lot of pre-Bitcoin attempts at a cryptocurrency represented something else. So I think we talked about this in the first lecture, that there would be this, owning this token represents an ownership share of a certain amount of gold or a certain amount of dollars held in reserve, etc. But Bitcoin by themselves don't represent anything greater. They exist as a part of the chain itself. But they could represent something else. We just all need to agree on it. Right? Just like we agree that Bitcoin has a price. Okay, we could agree that we're going to use this ledger to represent something in real life. So we actually have seen this a lot on non-Bitcoin chains. So there are a lot of instances, for instance, of using non-fungible tokens as representations of ownership of a piece of artwork on Ethereum. But we actually can use a very simple blockchain like Bitcoin also to hold property. So we don't need a smart contract or anything like that. So assume that we have some particular UTXO that represents ownership of something. So the ownership of a bike is whoever can prove ownership of a particular UTXO. We then can use that UTXO in a transaction to transfer ownership. So we know that the person who owned this UTXO, they then spent it. It became spent, so it's no longer theirs. It goes to some the value behind that goes to someone else. So we now have perfect traceability. We can follow who owned this piece of property from one account to another. And any account can prove that they own it simply by signing a message that they own this account. So we now have perfect traceability. Well, perfect at least until a person loses their private key. But if we did have this, well, we don't have to have title insurance, for instance. If you're not in the US, I know other places don't have this. Title insurance is basically insurance you buy when you purchase a home or other property that somebody else doesn't have a lien against it, that they don't have some ownership of it that you weren't aware of. So, for instance, there may be a tax lien that the previous owner owed some taxes and didn't disclose it to you. Without title insurance, then you may be liable to pay the taxes on that piece of property after you bought it, even though you had no idea because the lien was actually on the property. And title insurance protects you from that. But if there is a particular ledger where you can look all of this up and not have to look through all sorts of paperwork from back into the 1700s or whenever to see what sort of liens or taxes might be owed on the property or anything like that, you can imagine this would make property transfers much easier, much cheaper, and much safer. All right. So this comes from the fact that in Bitcoin, UTXOs are not fungible. Right? So what we mean by fungibility is a good where all units can be exchanged for each other. So, for instance, if I buy an ounce of gold, I generally don't care where it came from. If it's just an ounce of gold, it could have been melted down from a Nobel Prize. It could have been just gotten straight out of the mine. It could have been melted down from some old coins. I don't really care, and it's essentially impossible to determine. I'm sure there are ways with looking through impurities, but for where did this come from? But generally, an ounce of gold is worth a certain amount, and every ounce of gold is worth that certain amount. Or if I trade you a penny for another penny, it doesn't really matter. Again, unless you have some sort of rare penny or something, they're generally fungible goods. Bitcoin is not fungible, though. One UTXO is not like another. Why is that? We can see where it came from. We can always trace a UTXO all the way back to when it was part of a block reward. And this has benefits and drawbacks. So a benefit, obviously, are doing the kind of things that we've already discussed, like smart property. But it's very easy to verify a whole Bitcoin blockchain because we can see where every single transaction, we can follow it back to where it came from. But the drawback, of course, is in terms of anonymity, right? Since we can track provenance, we don't have the equivalent of cash where I can spend $1 at this place and it doesn't matter if I got it from church, the church was helping people by giving them money, or if I got it from gambling, or if I got it from selling lemons. Cash is cash, right? There's that old saying, like money doesn't smell. It doesn't matter if you got it from cleaning up sewers, you still have money, right? Or money. His money is as green as anyone else's. Bitcoin is not like that. Okay? Some of Bitcoin may have been traced to the Mt. Gox hack or other hacks, and people may not want to deal with it. There have been instances of people paying significant premiums for Bitcoin that has come directly from a block reward directly to them. So they know that it's not a dirty Bitcoin. So again, benefits and drawbacks to this system, and different blockchains have different solutions and opinions on this. Obviously, on one end of the spectrum, is something like Monero, where Monero should be entirely fungible. But of course, there are drawbacks in terms of being able to verify the blockchain easily. And then Bitcoin, which is entirely 100% traceable, and you can see exactly where things came from all the way back to their block reward. So there is a spectrum, and there are other coins like Zcash that has transparent and anonymous transactions. And again, there are different ways to slide that bar. But there are, again, benefits and drawbacks. There are very few essential good things in any software engineering project, let alone blockchain. Generally, everything you do has trade-offs. Okay, so if we can use these UTXOs in Bitcoin to represent other property, could we use this to overlay our own services or represent even our own currency? So obviously with something like Ethereum, where you have, or other smart contract chains, you can just write some code to do this. But we actually can write something on top of Bitcoin. So there's a good example of this with US dollars. There is this track me that where'sgeorge.com on dollars you will occasionally see. And this allows you to see where this particular dollar bill has been. You go to the site, you enter in the serial number, and you say, yay, this bill went from whatever, DC to Philadelphia to Harrisburg, whatever. This is running on top of the Federal Reserve notes, right? The actual dollar bills. It's not part of it. It's not code running on top of it. It's running. It's not code running on top of it, but it's additional functionality added to particular bills that do not exist elsewhere. So there is such a thing as an overlay currency on Bitcoin. So here we're still using the underlying Bitcoin network, but we're going to reuse specific Bitcoin for non-Bitcoin purposes. So you can always use this Bitcoin as regular Bitcoin, but it has additional metadata that lets you do other things with it, have your own currencies on it. We can take this a step further and add some metadata to a particular UTXO, and this is called color. It's really just some bits. It's just a number, really. And we can do everything that we normally do with Bitcoin, like transfer these, but we now have these tokens running on top of the Bitcoin network. So we get this security of Bitcoin, right, which is an extremely secure network, but we get this additional functionality that we might want to add to it. So colored coins, they were very popular, this idea a few years ago. Turns out this is much easier to do with smart contracts, but the idea is still out there, and I think it's interesting seeing, again, from a very basic perspective, or a fundamental perspective, I guess, what can be done with this basic blockchain scheme. And this is used for all sorts of things. So one is securities. You could use it to represent ownership of stock or a bond or an annuity. It allows you to make things such as tontines, where the last person to survive gets all the value that was stored, pooled together. It could represent physical property. We've already mentioned real estate, but vehicles or other property, or even virtual property. So one of the most famous examples is CryptoKitties. People can own these kitty representations or domain names. So like the Ethereum name system, ENS, allows you to make accounts like laboon.eth. That's a virtual token. It is represented on the Ethereum network, which is itself in a sense sort of virtual, and represents a separate virtual token. So we're rather abstract here. Bitcoin also lets you gamble, right? So we can have provably secure multi-party lotteries. So a very simple example of this was every party picks a large unique number and publishes the hash of that number. Right? And then every party reveals X. So, and then others can later verify that the hash of X equals the originally published hash. And then you just sum up all of these, take it modulo n, and whoever that is equal to, whichever party is that is equal to, gets the Bitcoin that was put into it. So here we have a secure way using our commitment scheme to commit to, we just use our commitment scheme to put this data on the chain. And again, it's secure. And we could do other things like look at the hash of a block to get some sort of it's not a good source of randomness, but you can get some randomness from the hash. Obviously, that can be modified, right? So there could be block withholding attacks and things like that. But there certainly are ways to have secure or relatively secure lotteries that are entirely done on chain. So I just mentioned that's not perhaps a great source of randomness. There's a problem. Randomness is a very difficult concept, and computers are very bad at it. And there are a lot of stories of people who broke systems because they found some hole in the randomness. And I have a whole list here. Some of the interesting ones, eudaimonic pi, which is about people discovering a way to figure out what hole a ball in a roulette wheel was going to land on, busting Vegas and bringing down the house, about blackjack, same with beat the dealer. There's been some lottery rigging. But Bitcoin block hashes, they're not exactly random. Again, there are some biases. Obviously, they have to be below a target. We can see how they're generated, and there have been some, there are some things like block withholding attacks. But could we use them somehow as a seed, right? To use for our systems, right? Our own systems. So this is similar how if you've ever seen a church raffle, they don't pick numbers themselves because that's something that can be easily gamed. But they'll say, all right, we'll use the state lottery numbers, which are much harder to game. Okay? So they're going to outsource randomness generation. There actually are some other ways to get randomness, but so for example, the National Institute of Standards and Technology, Standards and Testing at the in the U.S. provides an actual randomness beacon, so you can look at the randomness beacon and get some randomness. Of course, computers can't generate random numbers. The best they can do is pseudo-random. But they can get input from their environment as a seed and provide some relatively random values that can help for more complicated things than lotteries or non-interactive versions. Like our secure multi-party lottery required some interaction because everybody had to enter their guess and hash it and publish the hash, etc. But there's a problem here. Everything on a blockchain is going to have to be deterministic in some sense. So if we want to get randomness, well, we can do things like use like a verifiable random function, which again is still deterministic, but allows you to produce random numbers based on a seed without using sort of your public key cryptography to commit ahead of time to how you're going to generate these numbers, but not let others, these pseudo-random numbers, but not let others know what they're going to be or be able to calculate them ahead of time. But if we want to get true randomness from outside the system, we have a problem. And that problem is called the oracle problem. So an oracle, sometimes also called a data feed, is any place that injects external data into the blockchain. So this can be very useful, and not just for randomness, for any sort of tracking information, right? So if you want to know like what the historical stock market data was, or if you're using like a blockchain to hold to cover supply chain management, where were items at a particular time, etc. But this is very, very difficult to do in a trusted way. Blockchains generally They trust what's in them, and it's very easy to prove that it's true, but it's very difficult when we're getting data from outside the system. So this is known as the Oracle problem. How can we ever trust data coming in from off the blockchain? I can have a particular entity sign it to prove that they are the ones who sent it in, but how do I know that it's actually right? How can a blockchain know what the weather was in Omaha yesterday? It doesn't. It has to accept things on faith. So there are a variety of ameliorations out there. So for instance, you could have a market for oracles, and there could be different oracles competing. You could have punishment for violations, so that there's some sort of Bitcoin or tokens in escrow if you try to send in incorrect data, and people can challenge you. It could be that you have to have multiple oracles, and they have to agree within some small amount. So there are a lot of problems with oracles. We'll talk in the next class about some of the things that can be done once we have oracles, and taking some of the potentialities that we discussed in this lecture and seeing how they're used in real life and what sort of applications we can build from them. So I hope you all enjoyed this lecture, and I will look forward to seeing you in the next class.